Okay, assalamu alaikum class. So today we are going to discuss about microprocessor interfacing. Before jump to this section, we have to know what is microprocessor, we have to know about microcontroller, and we have to know the basic integration of the microprocessor with proper integration, with proper interfacing. Okay, so it's a very tough course basically if you want to know the details of the microprocessors, the memory size, the pipeline, and the other procedure actually. So you have to know the basic details, basic diagrams, flow charts, memory orientation, size, EPROM, flash memory, and all the stuffs. Okay, so to make it more easy, to make it more compact, I just want to explain with the basic mathematical equation, with basic general concept that you will get to the point and come to know in a very easiest way and put simplest effort to get the outstanding output. Okay. Before that, I always suggest you to make the subject very relevant to your environment, to your society, and to your common concept. Okay. Let's say before going to the microprocessor, I am just going to give an example why you should know about microprocessor. So first of all, I have talked about any ideas before that? No, this is your first class. So this is the lecture 1, and I am Abu M. Fuad, the lecturer of the Department of Tripoli of UOS, University of Scholars. Okay, so everyone has a tank in your house, okay, and it is always filled with water, right? So you have the water on your tank and okay, thank you. So please, thank you. Obviously you have a tank on your terrace, right, top of the house, and that tank supply what? Water actually to the particular level, level 6, level 5, level 4, level 3, according to the demand. So whenever you just push on the switch, turn on the switch, and let's say as a circuit, and as a system, okay, connected system, and you're just turning on the switch, the motor gets started and start rotating and pull out the water from the ground and fill the tank in a very simplest way. And after filling the tank, is it possible to make the perfect filling? If there is estimated shade over there and you just want to fill at this barrier or this stage, can you say and take a hand on your left chest and can say, sir, we always fill in this range, like say from 0 to 10 meter, and it exactly stopped to the 10 meter. Is it possible? How is this possible? Before that, how many waters we have been wasted every time when I was just going to fill the tank? Every time you have wasted lots of water. How? The sound of the water. Okay, fine, the water is going down, there's some sounds of the water, it seems that my tank is full right now, isn't it? So the water just boom up from there and you can find some water over there to the tank, then you will listen or hear the sound of the water and then say, okay, I have to switch off the motor that's basically connected with the tank. Okay, so it's not possible to make the optimum voltage, to make the optimum size to the optimum height and exactly lock it down to the 10 meter. It's not impossible. It's not possible in your own way, in manually. But do you rethink about that? Okay, may I manage the energy or may I save the water, or is it possible to save the ultimate water that has been wasted so long? That has been wasted for a long period of time. Have you think about that? Obviously. So here you have a plan, you have some system. As an electrical engineer, you can implement a system over there. That system is what I will tell you about that later. Before that, I am asking you something. Let's say if I make 2 range over there, number 1 is level 1, number 2 level 2, number 3 is level 3. Okay, so level 1, level 2, level 3. 3 is the optimum height 10 meter of the tank, 2 is the 5 meter, and level 1 is something like in initial position or 1 meter something. Okay, we can execute this, we can overlook this 1 or 2, let's say it's 0. So we can set level 1 and level 2, okay? Whenever you just set level 1 and level 2, it means there you have put a red mark over there, or put something that you can know, okay, now my water is 5 meter in height. Now my water is 10 meter in height. Okay. So we have a plan to execute this in a different way. How? Let's build a system. The system will take the inputs from the environment, will take the inputs from the tank. How? The water level is growing up, is uprising stage, isn't it? Whenever it comes to 5, you can set a piece of copper, a piece of iron, or any metallic something, right? And that metal is considered to what? A sensor. So if you set a sensor over there, whenever this water goes up, it will touch the sensor, isn't it? Okay, it will touch the sensor. Then you probably may know it comes to 5 meters level. At how? You need to set some indicator. Okay, you need to set some light over there, you need to set some sound over there. Whenever it comes to 5 meter, then the lights will turn on. Okay, so when the lights will turn on, from the outside of the scenario, from the outside of the tank, you can see that, okay, fine, it's now at 5 meter. Okay, so after that, when it comes to 5 meter stage, then you can say, oh, there's need to be more 10 or 15 minutes to make it fulfill, or to take the level at 10. Okay, then you may have some chips, have some coffee, or you can do your own task, and after 10 to 15 minutes, you have a reminder, okay, let's say at what stage are he or are it is now. Okay, so when it comes to 10 meter, there will be another light, like this light will be yellow light, as like traffic, and this light will be red light. Red light means what? That is fulfill, okay? And after that, the water is going to what? Burst out, or it goes down from the tank, or the water will be wasted. So to save the water, we will set a level of 10 meter as well as the previous version that we have been set to the 5 meter stage. So we will put a sensor over there, the water will touch that sensor, and additionally, you will show a light. Now you can say, sir, I will stay in my house, the tank is so much far from my apartment. It's like I'm staying right now at first floor, the tank is now at 10th floor. It's not possible to go every time to the terrace and let's say watch, oh, it's now 10 meter, okay, let's get down. It's not possible from me. So there will be a possible condition or a system you can develop over there. What? You can add a sound, isn't it? So if you put a horn, your cycle horn, your buzzer or alarm, anything, in addition with what? Red light, you can set a buzzer or alarm. Okay? So whenever it touches that level, it will start making sound. So after hearing the sound, you are familiar to the sound, and after hearing the sound, okay, my tank is already full. So I have to turn off the switch. Now question to you, if the tank is 10 meter in height, will you set your height to the 10 meter or less than that? 10 meter. If your tank is in 10 meter in height, total height in 10 meter, so you want to fulfill the tank. So if you want to put that red light with the buzzer to set an alarm, to set an indicator, are you going to set that indicator to the 10 meter or lower than that? Or slightly lower than that?
Almost full, sir.
Almost full. So you are going to set that alarm, right? You are going to set that indicator in your own way. Okay. So are you going to set that alarm to the 9 meter or 9.5 meter or exactly 10 meter? Exactly 10 meter. So you are staying at the exactly what? Some distance, is it fewer or lesser than that? Or slightly fewer, okay, slightly less than that, because you are at the first floor. So whenever you are just setting the level at 10 meter and the tank is full, what is the efficient of your system? To make it more efficient, you have to put it to the 9.5 meter. Do you got my point? Because whenever you are just going to uprise from here, you're going to take the stairs and go to the terrace and watch over there, oh, it's full. It takes time. So you have to save that particular time according to your height. Do you get my point? And whenever you get down, you will see, okay, it's full now. Because the red light is what? Bumping, or red light is showing your alarm, showing the red indicator. Then you just turn off the switch. It seems that the water is not going to be wasted. Okay, so you have already finished the basic scenario, the basic phenomenon of microprocessor. That's a very suitable example with your house that has been set over there. So ultimately, as an engineer, we have to save the energy. We have to make the system more efficient. Okay, let's say the lights are turned on. Okay, somehow you forget to what? Turn off the light when you're just getting out of the room. So ultimately, within few hours, no person is going to come in this room. Then what will happen? The electricity bill will automatically generate, the loss will be happened, and moreover, ultimately you are losing the energy. You don't utilize the energy. Okay, so you have to be liable for it. Okay, for that reason, you have to make a system. We are man, to err is a human. We can make mistakes, right? So undoubtedly, we forgot to turn off the light, but if we make a system like we have been reached to the home, now I have been remembering that, oh shit man, I have just forgot to turn off the light. So if you have the mobile phone and it is connected to the internet, this system is going to be same to the internet. With the help of the IoT, Internet of Things, you can turn off the light over there through your app and the lights will turn off from here. That's the indication of IoT and the advanced version of MCU. Okay. Now, to make it more generalized, if there is a sensor means what? It will take inputs. So, the sensor is something like that within 5 minutes, there is no person in the room. So, the sensor will calculate, yes, there is no person in the room. Okay. So, you have got out from this room. So, there is no person in the room. The sensor will calculate, okay, if there is no value, that means there is no person in the room. So, there is no person in the room, the lights are turned on and my system is turned on. So, I have to turn off my system which is connected with the light. So, the system will off automatically as well as the light. So, the sensor will take the input and the lights will turn off. Now, let's say, so do you get the ultimate result from here? I mean, how this happens actually and how it executes?
Yes.
Okay. So, let's talk about the lights. So, there is a sensors. Okay. So, there is a sensors, right? It will what? It will take some inputs. And there will be some middle box, it's a magic box. Okay. And there is another box which will indicate as output. So this is the sensors like PIR sensors, IR sensors or motion sensors, whatever. So we won't talk about the magic box. We'll talk about later. What about the output? So output is the LED or these lights, sounds or whatever. So I repeat, you forgot to turn off the light. The sensors will calculate what? The sensor will calculate whether the room is full or empty. So the sensor has already been calculated that there is no one at there. So it will generate some values. The value is something what? 0. As there is no person over there. Now it will turn off the light automatically whenever it gets 0. But is it possible the sensors can generate some values in its own way and turn off the light? So there is some media which can process the value that yes, your value is 0, now you have to turn off. Yes, your value is 1, now you have to turn on. It's like Boolean system, 0 and 1 something. So do you get my point? So there is a middleman, there is a magic box, that is the ultimately processing unit. Okay, that is the ultimately processing unit. Okay, so we will say that MCU, microcontrolling unit. Okay, so this controlling unit called controlling unit, MCU microcontrolling unit, controlling unit. So that's the ultimate controlling unit, that is our MCU. Okay, so the best example as an MCU is this board. Okay, this is the most familiar board as known as Arduino board. So one of the most familiar and well known to the research enthusiasts, engineers, and the hobbyists as well. So this is the most familiar that have been shown to this slide, and so on with this board. Okay, so there are some different particles, elements over there that is excreted and integrated with the particular element and comes up with a new board. So it's a PCB board, printed circuit board, where all the components have been set up, put over there, and soldered in its particular hole. So ultimately there is no wire over there. Okay, so the wire is the basic diagram that has been internally set to its board. So you have to play with that. You have to make some projects over there. So this is the magic box, the MCU, where the sensor will take a 0 or 1 something. It will generate it or it will calculate that value, because the sensor have no sense to calculation, to execute something. So it will take the value from over there and execute in its own way according to the command. And the command you have been set up over there, it is called sketch. So what is sketch? Sketch is a summation of codes. Whenever you write something, if, else, integer, 12. So whenever you write some lines, these are the lines of the codes. And whenever you merge the ultimate codes, that is called sketch. So you have to upload the sketch over there, and that will what? Evaluate your sketch according to the inputs and outputs, and the result will come down as a turn off and turn off the light. Okay, so it is just a simple board. You have to command him in his own language. If you say him Bangla, light bondo koro. If you say him in English, turn off the light, it won't understand anything. So in his language, you have to command him, and that language is Arduino language. So to know that this MCU board is what? Arduino board. To communicate with him, what is his language? Arduino language. So you can say, sir, I didn't heard everything about Arduino language. How is this possible? So Arduino language is specially for the Arduino boards, and that language is preferred, basically is the interface of C++. Okay, so its basic, the mother nature is from the C++, and that modified version is we are calling right now or familiar to Arduino language. Okay, so that's the Arduino board, and with the help of the MCU, we have come to know that the output side and at the input side. Okay, now let's take an example in a very prominent way, and you will get to know about that. Okay, I am just not rubbing this thing or not erasing this thing. So this is the language of what? Academical. Now I will explain it in your previous experience. Okay, do you know about the function? Do you know about the function? What is function? Can you please say an example of a function with an equation or something?
f of x equal to x plus 3.
2x plus 3.
When including x value like 1 to 3 is,
Okay.
then we get
Another value. Okay. So the function is something that is generated from an equation, and that equation is what? Execute some values as an output, which depends on some particular individual inputs. I repeat, particular individual inputs, and every inputs should have a particular outputs. Do you get my point? That is called a function. Okay. So what's the example? F of x is equal to y is equal to what? 2x plus 3. Do you get this? Okay. So please say some value over there to execute the value of y. We have to put some value of x. 1. So what will be the value of, if the value of x is 1, then y is equal to what? 5. Let's say take another example of as an 3. So if the value of x is 3, then y is equal to what? 12. Let's say 9. So to get an output of a function of a y, we are putting the value of x every time we are getting different values. So what is the input over there? So let's say input, output. Okay. So input is what? X. Output is what? Y. Y means what? F of x, isn't it? So y means f of x. So y is generated from x, and x is depends upon no one. Okay. So he or she is independent. So are you getting my point? Where I'm jumping, or I'm just supposed to explain you from which perspective? So there is something that is the magic box over there, and you will get as an output. So what is the magic box?
2x plus 3.
2x plus 3, I mean the equation, isn't it? So the equation. So who is the processing unit over there? The equation. If you don't have any equation, like if you say x is equal to 3, how can I get the value of y? How can I get the value of y? So if you have the value of x and where in a particular equation, then you can get the value of y as a result of that equation that is considered to a function. So are you getting my point? So if you are getting the value of x, you are getting the value of y particularly through a equation. So that equation is a magic box. So the sensor is independent to take the values from the environment. You can put any kind of values over there. It will sense whether the human is present or not, whether there is anyone is doing such work or not, or it can be fire alarm, that whether the heat is not basically heat, it's about the temperature. So whether the temperature is uprising or not. More example, please. Any example more than that? The upper level, the water sensor, the rain sensor, I mean, the soil sensor, whether the soil is okay or not. So every time, every sensor, I mean every X is taking the value from the environment, from the particular system. It's his own choice. Then he has nothing to do with that. You have to send the value to the equation, to the magic box, and that magic box is the microcontrolling unit. That unit will process the value according to your system, according to your protocol, and then what? Execute the output with the particular equation. So now are you getting this, that how this equation and function is very highly connected with this microprocessor? Okay, so now you having come to know about that in class 9, 7, 8 or something, and you are just dragging that academic background to make your present academic background with more beautiful with the particular mathematical equation. So maths is all over there, just you have to drag it out and put it to the particular place, then the life is beautiful. Okay, so today we have learned a lot, and video time. How much has been video time? 15 minutes only.
No, sorry, 24 minutes.
Okay, let's say within 6 minutes we are going to cut it down and jump to the next class. Okay, so that's the basic scenario. Now I just want to get some example from you with the implementation of MCU. Anyone, any example like fire alarm sensor, water sensor, soil sensor, what? Sonar sensor. Okay, so you have already heard about that. Whenever you are just talking in front of a hall room, the sound will automatically comes to you as an echo. If you are shouting to a hill area or in an open space where there is a probable particular obstacle in front of you from a particular distance, and the sound will automatically echo from there. If you are shouting to any well I mean where the water is dragged from the with a particular tube or coil or something with a rope, that is called well. Whenever you're shouting to a well, then you will listen to your own voice as an echo. So how it is possible? It means you have come to know that S is equal to Vt. Okay, so whenever you are hearing your own voice as an echo, it means twice S is equal to Vt. Isn't it?
Yes, sir.
Okay, so that's the simplest physics equation which has been implemented to the sonar sensor. Okay,
Sir, ultrasonic sensor?
that the ultrasonic sensor and sonar sensor is almost same. Okay, so okay. Yeah, that's the sonar sensor, ultrasonic sensor is almost same. Now, is there any sensor they are going to talk about? Okay, we will discuss about later. Now, to know about more this component, this 80 mega 328P, the other capacitors and the other stuffs, we'll know about the next class. But before that, we have a topic that is our main concern, is the microprocessor interfacing. So what's the difference between microprocessor and microcontroller? So there is a basic distinguish.
Microprocessor have a big ROM and RAM. And
Okay, so you are talking about the memory size. So microprocessor has a memory size and microcontroller has a less memory size, is it? Okay, before jumping to memory size, I have to know about what is the execution, what is the role of it. Okay, like say you have PC in front of you. So the PC is running with a heavy load, with a heavy calculations, with a heavy different type of operations. Like you can play over there, playing games over there, you can play cards, you can make some Word file, you can generate some images, you can browsing the internet. Okay, you have to do lots of stuffs. So to do the lot of stuffs, you need a heavy RAM. The more you put some RAM over there, 4 GB, 8 GB, 16 GB, the more faster you can work. Okay, then what? You need a very good memory storage size. Okay, then what? Then you have a very strong processor that can consume very high amount of load. So high amount of pressure, consuming power, very integrated, better RAM, ROM. So all these stuffs make a processor what? A very strong community, a strong parameter that can operate easily to the computer, in basis of computer, in basis of laptops, mobile phone, tablets, whatever you have. Okay. So that's the basic scenario you have to know about that. But whenever you're going to use the microcontroller, this board, for a particular task is the suitable one. Let's say you can use this task for turn on and turn off the motors with the particular indicators. To turn off the light, you can use this particular system. So for a particular execution, microcontroller is the best. But you have a lot of tasks to do, you have lots of operations, that is not going to be your best choice. It's be the worst one. Okay. So whenever, according to your task operations, you have to choose whether I'm going to processor or what? Controlling unit. Okay. So the both are almost same, but there is some basic difference in size, in ROM, in particular task. In cost, basically, it is priced in 600 or 700, but microprocessor, Intel, Ryzen, 20,000, 15,000, 25,000, okay, Core i7, Core i5, Ryzen 5, AMD Ryzen basically. Okay, and then it has a strong RAM, I mean random access memory, 32 GB, 16 GB, but Arduino has a very small amount of RAM because for a particular amount of task, you don't need a very huge amount of RAM. You need what? You need something like 2 KB, yes, exactly, 16 KB, 32 KB, so in kilobyte range. In computer, you have a size of image which is 1 MB, 2 MB, 3 MB, 5 MB. Okay, so that's it. And you have an Ethernet port, you have a communication port, or more than that in computer, which is integrated to the microprocessor. But whenever you are just using a microcontroller, you have particular specification like I2C protocol that is relevant, that is very familiar to I2C protocol. Then what we have UART, okay, you have SPI, serial communication port, okay, like how you can actually integrate it. So microcontroller is a compact integrated circuit, this one, and this one that is my MacBook M1, and this TV, this laptop or computer, the handset that's I'm using right now, phone. So every time it's a single IC chip, okay, that is generated from what? From a lots of billion transistor, and it is operating to the multiple task. So a single chip obviously more stronger than the microcontroller depend upon the task. So this microcontroller is what? Is for the single operation. It is a low amount of ROM. It is very low in cost. I mean very cheap. And what it's have? It's a small size of RAM, ROM, EPROM. There is another RAM it has that has been that existing right there. So to particular task, it is the best suitable one. And if I come to the microprocessor, what we have is a very high amount of RAM, okay, high size of ROM, cost cheap or expensive? Please, the cost of microprocessor, cheap or expensive? Expensive, it's very costly. Then what I can say? We can connect external memory over there to the microprocessor. That is not possible over there. It has some Ethernet port, USB port, USB type B, type C, and lots of ports over there. That is, you can see the backside of the casing of your PC. Okay, so these ports has been generated from the microprocessor, from the processing unit. Okay, so it is then extruded to the all over there and spreading the wires, and that is, which is connected and dragging out from the controlling unit, from a motherboard to the what? Casing of the PC. Okay, then I can say moreover, I can say that it is a very high power consuming device, and that is very low power consuming device, because you have to operate a low amount of task or a simplest task. So as a beginner, you have to choose microcontroller. Okay, so that's the end of the scenario, and so yeah, I hope you have got the ultimate scenario or result of the microcontroller, and that's the basic class of our. I hope that you have learned something new, and I have tried my best to put your bucket some new information. Okay, so that's it. You may turn off the video right now.